This is number 37 right out of the book. It says a particle moves in the plane so that its position at any time t greater than or equal to 0 is given by those two functions. And this one is not highlighted, so you're going to have the use of a calculator, or you will need a calculator for this. And not only that, if we look at letter A, it says find the velocity and speed of the particle when t equals 5 pi over 4, so it suggests that we're evaluating this. And when we're evaluating, and it's not specifically asking for just the derivative, let's use our calculators. But however, at the same time, we need to show our work. We need to prove that we actually know what we're doing, not just getting answers. So we'll say, well, the velocity is equal to x prime of 5 pi over 4 and y prime of 5 pi over 4. So when a grader is looking at this test, if this was on the test, whether it be me or someone down in Kansas City where they actually grade all these, they're going to look at that and go, well, yeah, they know what they're doing. They've suggested I'm taking derivative to find these values. And then even the function value suggests we are evaluating this. So on the calculator, we can go to math number 8 is n-deriv. So we're taking a derivative with respect to t, because I'm in parametric mode. Yours probably will say x's. It doesn't matter. And then we have sine of 4x. Yours probably says x if you're in regular mode rather than parametric. And then cosine of t. Yeah, that's fine. You're welcome. And then we're evaluating at 5 pi divided by 4. Enter. 2.828. 2.828, comma. And then I need the derivative of sine 2t, which is 2 cosine 2t. We know what the derivative is, but let's just let our calculator do the work. So math number 8. This is with respect to t in this case. Yours might say x's. Sine of 2t and 5 pi divided by 4. Enter. 0. That's the velocity vector. So what have we found? Well, the velocity vector is, when it's in component form, it starts at 0, 0, and then we have 1, 2, 3. There's the velocity vector right there. So it shows how the length is the speed, and then it also shows that it's going straight to the right. So that's what we've actually done. B, draw the path of the particle and show the velocity vector at t equals 5 pi over 4. So we're going to take that vector and we're going to show where it's happening. But we need the graph first. So we go to actually go to mode. You'll want to be in parametric if you're playing along. Y equals sine of 4t cosine of t sine of 2t. And then for the window for this one, if you go to negative 10 to 10, that's way too big. Negative 3 to 3s seem to be what you're looking for. So graph, and it's kind of a neat little graph here. It's like 2 hourglasses. So it says draw the path, and I know that with parametric we're interested in the direction it goes and the actual path. Don't worry too much about that. We just want to get a basic drawing of it. 1, 2, 3, 1, 2, 3, 1, 2, 3, 3. And it's a big hourglass, kind of like that, and a little hourglass, like that. So that's good enough. That just is a rough little sketch of what's going on. Now it says, here's the important part. Why I'm actually showing this problem is more for letter B right here. Draw the path of the particle, did that, and show the velocity vector at t equals 5 pi over 4. So we're going to show this vector, but we're not going to put it on the x-axis like it should be. We're going to start it where the particle is at 5 pi over 4. Let's go back up to the original right here and find out, well, where is that point? And I'm not going to use chevrons because I'm finding out where is the particle at 5 pi over 4. So I need sine of 4 times 5 pi over 4 cosine of 5 pi over 4. So those cancel. Sine of 5 pi is 0 times negative square root of 2 over 2, but it doesn't matter because that's going to be 0 now. The y coordinate where this particle is sine of 2 times 5 pi over 4, which is sine of 5 pi over 2. 1 half, 2 halves, 3 halves, 4 halves, 5 halves. So sine of pi over 2 is 1. So this particle is at 0, 1. So the particle is right there. That's where it is. And then we're going to represent the speed of that with the velocity vector. And the velocity vector is right here. It goes to about 2.828. So we draw, remember vectors, they don't matter where they are. They're the same vector. So we'll represent where it is with the speed also. Any questions on that right there? That's what I would expect to see on a test or a quiz or homework or whatever. Then C, does it say find the speed? I think it does. Draw the path of the particle and show the velocity vector. No. Is the particle, oh, I should have found the speed up here, and I didn't do that. So for letter A, let's back up. There's the velocity vector. And when one of the variables is 0, the speed is just 2.828. Speed. Because, I mean, you can still do the magnitude of this velocity vector. It would be 2.828 squared plus 0 squared. Well, that's going to go away. You're going to square root a square, and it's just 2.828. Goes right back to what it was. Letter C is a particle moving left or right at this point. So right before the point, I don't know exactly. I don't know if it went this way or it went this way. Let's say it went this way. I would have a velocity vector doing this because that would be the direction at that point. At that point, the velocity vector might look like that. Well, right at that instant, when t was 5 pi over 4, that particle was moving horizontally. So in other words, in this case, the answer to letter C is simply, at that instant, it was moving to the right.